Excellent. Well, welcome all to the Ciudad de Mexico A forecasting hackathon. Whoop, whoop, whoop. I see we have a full room here. Excellent. Excellent.
So,
I'm going
welcome
to be
all
talking a bit
to
about
the Ciudad de
what
Mexico.
A forecasting is. I'm going to be talking a bit about things that we have done at Epoch in the last year. And then I'm going to give you a few ideas and a few resources so that you can get started on your journey to try to figure out what the heck is going on with artificial intelligence. I guess that before anything, I should just briefly introduce myself. I'm Jaime Sevilla. I'm the director of Epoch. My background is in technological forecasting. I do a lot of math, a lot of stats, and I think a lot about AI regularly. And I will be available through the hackathon for any questions that you may have. You just come to my office over there, and I will be super happy to give you any support you need. So let's talk a bit about the context. I guess that you three probably have heard a lot about artificial intelligence in the effective altruism community, but it's always good to clarify what's going on. We live in a pretty crazy time in which many tasks that before were thought to be really hard to automate have turned out to be not that hard to automate. We have seen many recent advances on text generation and a personal favorite of mine, image generation. And these kind of things are taking the world by storm and eliciting a really powerful reaction from many people, traditional artists. Together with that, we also see a trend in which people are gradually realizing that we have very little idea of how can we train these machine learning models in such a way that they follow the intent of their developers. A pretty famous example is right now with ChatGPT, which was heralded as an innovation in AI safety and alignment. Well, it turned out to still the security that was on top of the model is relatively easy to break. You can still quite easily trick the ChatGPT model into giving unsafe directions, for example, on how to build a Molotov cocktail and other things that presumably the developers did not want. So, with this in mind, what AI forecasting is useful for? In Epoch, we primarily think of three types of stakeholders that I do want you to also keep in mind where you're deciding what projects to work on, so you can choose to work on something that ends up being the most useful for the world. The first group that we work a lot with is grant makers, OpenField, who are really interested in getting a strategic understanding of AI, so they can decide where to focus their money on. An example of a strategically important question for a grant maker is how long the critical period in which we're going to have advanced AI, but not so advanced that's going to be risky is going to be for. If that period is very long, then what it makes more sense is right now to try to build a really large community of researchers, and later it's going to be taking advantage of this long period in order to do lots of empirical experiments that and so do a lot more useful research that if we just went full on doing research right now. That's an example of a question that's really interesting to grant makers. Another stakeholder that we think a lot about is AI governance researchers. In order to manage the risks that come from artificial intelligence, it's going to be important to coordinate with companies and possibly governments to try to deploy effective regulation of these new technologies. And for that, it's very useful to have a really a strategic understanding of for example, what are the key inputs that go into artificial intelligence? Should we be paying more attention to regulating data? Should we be paying more attention to regulating hardware? These kind of considerations inform what policymakers should be focusing on, and also they inform they help them develop effective policies that end up being feasible to implement, actually useful for mitigating the risks. Finally, a third group that we also have in mind is the technical researchers themselves. And this is in the same way that grant makers are really interested in understanding how long the critical period of advanced AI but not so advanced AI is going to be. This is also informs technical researchers. If technical researchers believe that maybe a thing that they are really interested in is when AI is going to happen. If AI is going to happen really soon, then technical researchers are incentivized to work right now with the techniques that we have try to make advances with like the models that we have, because the AI that's going to end up being like most relevant for like determining the far end consequences of like this technology is going to be very similar to the AI that we have now. Whereas if they believe that like the AI that's going to be relevant for like all these catastrophic risks is like the AI that's going to be developed like 40 years from now, they will want to invest more time in like theoretical approaches and like more abstract research that is going to be transferable across like different AI paradigms, even if like in 20 years we totally change the way that we approach AI. So these are like three stakeholders that you may have in your mind: grant makers, AI governance researchers, and technical researchers. And these are like three examples of like questions that they're interested in, like how long the critical period of AI is going to be, like what kind of inputs are important for like developing machine learning systems, and how soon transformative AI is going to be developed. Now, how can we go about this? At Epoch, roughly we follow like two types of research. There's the research that has to do more with data analysis, another part of the research that has to do with math modeling. The data analysis part is like quite straightforward. One big part of what we're doing at Epoch is like creating these data sets that have to do with like artificial intelligence, and then like applying like classical data analysis techniques to them, like visualizing the data, doing like trend regressions in order to understand like how the trend in compute has been growing over time, how machine learning systems every year use more and more compute to be trained. The second part of this is like the math modeling part, which helps us take these trends in the past and like extend them into the future under some moderate assumptions. So for example, we might be interested in like, given that the trend in monetary budgets used to train AI has been growing at this rate, like when are we going to hit a certain limit? What should that limit be? Like once like the budget grows up to like 1% of like US GDP, what do we think is going to happen then? Will the rhythm at which like money is going into AI slow down? Will it keep growing up to like a larger budget? This is the kind of work that goes into deciding what are the assumptions that you bake into these mathematical models that then allow us to gain like an understanding of like what do we think may happen in the next decades. So those are like the two kind of approaches that you can have in order to study the future of AI: data analysis and math modeling. Why do we think that this is at all like a good idea? Well, it turns out that in the last few decades, we have gained an understanding of like some regularities that have to do with machine learning, and in particular, regularities between like the resources that are dedicated to training the systems and the performance of like these levels. The big field of research that studies these regularities is called scaling laws. Probably Pablo can tell us much more about the scaling laws. He is our in-house expert on scaling laws. But the rough idea is that the scaling law roughly describes like if you use like this amount of data and this amount of compute, like and you follow like a recipe for like optimally training your artificial intelligence, what performance you should expect to see on it. And this gives you also like an easy way of like categorizing like progress in AI, right? Like you can think of like advances in AI as like roughly mixing three ingredients: the amount of compute that goes into the systems, the amount of data that goes into the systems, and like the amount of innovations, architectural innovations that are used that improve the scaling laws themselves and like the way that these AI systems scale with data and compute. All right. So we have talked a bit about methodology, and I have hopefully justified to you that this methodology has some promise, right? There is reason to expect some regularities in like the artificial intelligences that we're going to see in the future that are determined by the inputs that are dedicated to training the systems. Now I'm going to be I'm going to give you like a few examples about like research that we did at Epoch over the last year that actually fits very nicely into this scaling laws formula, because it's research that has to do with like the amount of compute that goes into machine learning systems, the amount of data, and the amount of innovation. So the first paper that I want to talk about is one about compute trends. So this is a plot about the amount of compute that is being used to train milestone machine learning systems over time. And what we can see is that it has grown exponentially. Fact number one. And not only that, but also there has been like a recent change. Like before 2010, like this was growing like relatively slowly. It was growing at like a pace of like doubling like every 20 months, which is comparable to like Moore's law. So like basically people were not investing more money into machine learning systems. They were just getting better computers. And with those better computers, they were able to train more powerful systems. But around 2010, like people like woke up to the potential of like scaling up AI massively. And and suddenly we see like this massive growth that has kept up to today, where like every 6 months, the amount of compute that's used to train this milestone machine learning systems has doubled, which is like an insane pace. This is like 4 times as much compute like every year. We also another thing that we saw is that in around 2014, like industries also caught up to this game and like started investing massively in AI, which caused like this one-time discontinuity where like suddenly we saw like massive training budgets that we hadn't seen before that were like 100 times bigger than what existed at that time. So this is like what we learned about compute. What did we learn about data? And like here, Pablo Villalobos has been leading an investigation about like the trends in the amount of data that are used to train machine learning systems. And like we learned that the amount of data that is used to train large language models has been doubled like every 15 months or so for the last 30 years. And then we asked the question of like, all right, if this trend continues, like when are we going to run out of data? When do we reach the point where like the AI is trained on like basically all of the internet? And even if you were to like transcribe all of YouTube, you will still not have like enough data to satisfy these growing demands. And extrapolating this trend and like comparing it to like the way that like the stock of data on the internet grows over time, we found out that it is likely that we're going to hit this limit sometime between like 2030 and like 2040. We shouldn't like give this like an exaggerated importance because there's like some promising early advances on like data efficiency that point to the fact that maybe this is not going to be as big of a constraint on like machine learning systems as like it might initially seem, but it's something interesting to keep in mind because this very probably means that we're going to see like at least a shift in like how machine learning is approached in the next decade, where like people are going to stop like gathering bigger data sets and instead are going to be thinking more about how to make a smarter use of the data sets that they already have. And finally, regarding innovation, we recently published a paper about algorithmic improvements in computer vision, where like we revisited some old results about like how the amount of how is the amount of compute that you need to achieve like a certain level of performance has decreased over time. And like, what we find is like a pretty rapid pace. Like it seems like every 9 months or so, the amount of compute that you need in order to reach like a given level of accuracy is like halving, which is pretty crazy to think about. Huge uncertainty marks on like these results, but this definitely points to the fact that like it's not only by growing your amount of compute that you can get better results, but also you can bring in like new innovations. Like the transformer architecture was like a really big innovation. The change from like sigmoid activation functions to like ReLUs was another type of like innovation. This also gives some results about like the amount of data, how the amount of data that you need to reach a level of performance decreases over time. But the results over there are like far more noisy and not as statistically significant. So I won't enter too much into that. So these are 3 examples of like results that we found at Epoch that allows us to better understand how AI is going to develop in the next decade, how it has developed in the last decade, and how we will develop in the next decades. And it's quite an interesting picture. Like before I was talking about like how performance is essentially like this combination of like more compute, more data, and more innovation. And it seems like on each 3 of these dimensions, like things are still like growing exponentially so, which leads us to think that we are not definitely in the amidst of an AI winter by no means. We're still going to be seeing advances in AI for the foreseeable future. So now what you can do in this hackathon? Well, first of all, I just want to introduce you to a few AI forecasting resources that you might find useful. We wrote down some research ideas in the EA forum that you can use for inspiration for your projects. We also have a really nice curated database of like milestone machine learning systems that are annotated with like the amount of parameters that they have, the amount of compute that they have, and the amount of data that they have. You can see that in our website. You have a very nice visualization tool that like Eduardo in the other room coded, and that it's a really good way of like getting an intuition of like what's going on with the systems. Finally, I encourage you to check out publications from other places, our website, of course. Also, AI Impact has been doing a lot of work on like understanding what's going on with artificial intelligence. The AI Index also publishes like an annual report with like the state of AI that year, which with very interesting insights. There's also this page called computerprogress.com, which is maintained by the MIT, and it's a collection of resources related to trends in artificial intelligence. And finally, Metaculus also has lots of questions about artificial intelligence that you can find interesting to get an understanding of like what the community thinks about the likelihood of different developments related to AI in the future. You can also find in the hackathon page a collection of more these and more resources that Pablo and Sven have curated. And now, some ideas that I want to sprinkle on you to get your creative juices flowing. So these are like some examples of like questions that I am personally interested in. The scope of some of these questions might be too big for a hackathon, but maybe you can make progress on like a partial aspect of these questions, or maybe you can use this as inspiration for like coming up with your own idea. So like things that I'm interested in, like one thing that I'm really interested in is like what's the base rate for like paradigm changes in AI? Like we saw before in the compute paper that around 2010, like the way that we approach AI like changed drastically from like having like relatively tame compute budgets to like a compute budget that was growing like every 6 months. And I will be interested in like understanding like how often these kind of changes, radical changes, happen in like within artificial intelligence and within technology in general. I think this will be really interesting to help us understand the chances that our models are like completely wrong and like useless. A second question, something that I've been discussing over EAG actually quite a bit with Hayden, is about whether transformative artificial intelligence is going to first be developed by a company or by a government. And this is a question that I think is interesting to talk about. You can like think about like the trends in like the budget that is used for like the systems. You can think of like analogies to like previous government efforts to like develop a technology, like the Manhattan Project or like the Apollo Project, and how these analogies carry over to like artificial intelligence. Another question that is in the mind of like everyone these days is like what's happening with like the China ban. Like recently, the US banned trading semiconductors and like advanced GPUs with China, which potentially has severely crippled their capability to like do AI research and like getting like a better understanding of like how much has this affected AI development in China could be strategically important. Another question is what's the labor input into artificial intelligence? Like how many researchers has contributed to like each of the developments that we have seen in the past year? Like how important is the input of these researchers versus the amount of compute and physical resources that the labs have? This is something that I'm also interested in, like understanding better. And finally, I think that's always useful and relatively easy to do is just reading through more papers and like gathering more estimates of like the parameters that of the models that are showcased in the papers, the compute that was used to train them, and the data that was used to train them. That's always like a really good useful project. And if you do so, please contact me because we will be really happy to include that data in our database. And well, those were like my examples, and now we have like a bit of a space for you to ask any questions that you may have, either about Epoch, AI forecasting, or any related topics.
Is there a way to measure the performance? I mean, because I saw the law that you guys think that data plus compute plus innovation is more performance.
That was kind of like a simplification, an abstraction. Like really, how the equations look like is more like this. That's on the left over here, and like different systems for different tasks. The performance for them are measured in different ways. Like for example, for large language models, usually what you measure is like the cross entropy of the model, which essentially it tells you like how good the model was at like replicating the distribution of data that it was trained on, essentially.